All right, I'm going to wander into the realm of scripting here. Let's get a share screen going. So once upon a time, Unity had three programming languages: JavaScript, C#, and Boo. Boo and JavaScript have fallen by the wayside, so we're left with C#, which is just fine. C# is a great language. The C# doesn't automatically inherit from monobehavior, so you'll have to add this here to a behavior script. We'll see other options for this later. Unity does this for you when you create a new script. This is a new script. It automatically does the usings. The class name is the same as the name of the script, and start and update are included. The class name, new behavior script, must match the file name. Public variables, the so-called member variables. We have two different types, public and private. Public, and these go before any functions. So up in the top of, after the class name and before any of the functions. These are global to the script, both public and private. For public, we include the keyword public with whatever type the variable is, its name, and an optional value. You've seen if you reset a function, the value goes back to being whatever is specified there. Variables inside functions are local to that function. We'll talk about scope in a minute. Private variables also go before any of the functions. They're also global in that script, but they're not accessible to other scripts. We can either just do a type, a name, and a value, or include the keyword private. There are also static variables that also go before any functions, also are globally accessible in that script. But they're also accessible to other scripts that reside in the same folder of the project view. So this can be kind of an interesting way to communicate between scripts. Data types are the more or less standard. We have the ints that are whole numbers with no decimals. We have the floats that are numbers that have decimals. In Unity C#, we must include the F. So 2.1F, 1F, we don't have to have a decimal, 100F, 2 decimal F and 2.1, those are illegal floats and will trigger a compile error. We have a number of different built-in entities, including the vector 3 that has X, Y, and Z values. We make a vector 3P as a new vector 3, that's the constructor. The X value, float number 1, float 1, 2, and 3. There are also 2 vectors and 4 vectors. We have the Boolean type, it's true or false, or potentially 0 or 1. We say bool, okay, for true, and we have a variable that contains the true value. We have enums, so here the game state enum, we could say my game is game state.start. It's one of the enums. These are kind of ways of having named constants. As I mentioned, the scope of variables, those declared in the body of a function are local to that function and have no connection to the member variables, the ones up above the functions that have the same name, nor to local variables in other functions. So we have this scope of the variables. Standard kind of operators, assignment, addition, subtraction, multiplication, division, the mod function, concatenation of strings is the plus sign, so string ABC plus string DEF results in the string ABCDEF. We have the increment operator, plus plus, and the decrement operator, minus minus. And as with most C-like languages, if we want to raise something to a power, we must use a mathf pow function, 6 raised to the 1.8 power. There are a number of preset functions that we'll encounter. I'll talk a lot about these as we go along. The awake and start are called when the script wakes up. Update is called every single game cycle or frame, as in frame rate. And we can, of course, declare our own custom functions. Custom functions must have a type. If a value is to be returned, and that return value must have the same type. If we're not returning anything, we can use the void. Then we have the name of the function, arguments that are explicitly typed along as we go. We have kind of standard conditional statements. We have if logic. The logic is something that evaluates either true or false. We have statements that execute on true, and else we have statements that execute on false. The logical operators, equality is 2 equal signs, not equal, slash equal, greater than or equal, less than or equal, and, or, and not. These are the logical operators from which we might make logical expressions that appear in our conditionals. We have a switch statement. We have my game is over, and then we're switching on my game. We have loading, running, and over. This is going to print game is over and then break. We also have the default unknown state. We have the truly terrible conditional operator, where we have logic, a question mark, a true statement, and a false statement. So my game equals X is greater than Y. If X is greater than Y, my game will be loading. If X is not greater than Y, my game will be running. I don't recommend this. We have for loops. We have for with the start value, I equals 0, the conditional I is less than 5, and the step counter I plus plus. So this will pass through the loop for I equals 0, 1, 2, 3, and 4, not giving us a 5 because of our condition. There's also a while loop, while some logic. While the logic is true, we have the body of the loop. In Unity, and this is not required, but we follow certain naming conventions that the editor takes advantage of, or that the Unity editor takes advantage of. One is that with variables, we'll try and use camel case, where it starts with a lowercase letter, and then as needed within the body of the variable, we'll include a capital. I'll show you later why this does an interesting thing. Keywords, things like var, if, case, switch, all of those are generally lowercase. Some Unity variables like audio and transform are certainly like this. Enums traditionally are all caps, so something like running. Functions, we use the capital camel case. So instead of beginning with a lowercase m, a function would start with an uppercase M, my function. This distinguishes between classes like capital transform and the variable lowercase transform, and we'll use the same distinction, distinguishing between a function, my function, and a variable that is the lowercase camel case. Classes, things like the scripts that we write, are usually capital camel case, so my script. I'm going to pause at this point and pick this up in the next video, so I'll stop the sharing here, and I'll end the recording.